Hello and welcome to Pep Talk with me, Mr. Pepperell. In this episode, I'm thinking about the power of the atom. By the end of this episode, you should be able to tell me how we generate electricity from nuclear fuel.
Well, in our last episode, we saw how we could generate electricity from fossil fuels that we can see here. And we also found out there are a couple of problems with this. So let's see if we can avoid those problems with nuclear power. So the fuel used in a nuclear power station is the radioactive element uranium, or in some cases it's actually plutonium, but mainly we're going to worry about uranium. Okay, now don't worry too much about why uranium is radioactive or what this actually means. We're going to cover that in P2. But what you do need to know is that the nucleus of a uranium atom, which I've got here, is unstable, and that means it can split in two during a process called nuclear fission. So in the process of nuclear fission, the nucleus of the atom can actually split in two. So why is fission important? Well, it's really important because when that atomic nuclei split, what they actually do is release energy as heat, a lot of energy. Now, because the uranium stored up in cans basically in the core of a nuclear reactor contains a lot of atoms, you get a lot of heat being given off. And what do we do with this heat? Well, this heat is actually transferred to a coolant fluid flowing through this pipe. In this case it's water. So the heat is transferred to the water that then flows through this pipe. Okay, it's pumped through the core, and when the hot coolant is then used to heat up water in a heat exchanger, which is this bit here. Okay, so the hot coolant flows through this pipe, comes into contact with this hot water here, and that water starts to heat up in the heat exchanger. And what that does is it turns the water in this part here into steam, and then we basically get the same process as in our coal-powered power station. The steam comes down here onto the turbine, spins the turbine. When the turbine spins, it turns the generator and generates electricity. So it's basically the same process as a coal-fired power station when you get to this side of it. It's just you're using a different way to make the steam over here. Now, hopefully you'll recall that the big issue with fossil fuels was that carbon dioxide, or CO2, was produced when they were burnt. Well, in the case of nuclear fission, nothing is being burnt, so there's no CO2 being produced, which is absolutely brilliant. But it's not all good news, because the waste produced by this fission process is radioactive and it's very dangerous, okay, and it stays radioactive for a long time. So it needs to be stored for a long time before it actually becomes safe. And also uranium, in the same way as fossil fuels, is a non-renewable resource. There's only a finite amount of it on our planet that will eventually run out.
So that's everything we need to know about how we use nuclear fuels in power stations. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.